Tonight we're going to be going over subtracting expressions, practicing problem solving. I'm going to start with all the odd ones, number 7 to begin with. It says rewrite the expression 14m minus 5 plus 8m. We must remember that whenever there's a negative sign in front of the parentheses, there's like a -1 sitting there. I have to apply that -1 to everything in there using my distributive properties. Well, -1 times 5 will be -5, and -1 times +8 would be -8m. All right, so let's go ahead and do number 9 now. Write an equivalent expression to 8k minus 5 plus 2k without parentheses. Okay, well, an equivalent expression, once again, we have the negative sign in front of the parentheses, and we can apply this -1 to everything in the parentheses. Well, -1 times 5 is -5. -1 times 2k is -2k. All right. Then we're going to have 8k. Well, we're going to use our commutative properties by moving our terms around. This is still a -2k, and this is still going to be a -5. Now I can combine 8k minus 2k, and 8 minus 2 is 6, so that would be 6k minus 5, and that's number 9. All right, let's go down now to number 11. Number 11 says two communication companies offer calling plans. With company X, it costs 35 cents to connect, and then 5 cents per each minute. Well, that's going to be 35 to connect. That's my constant. And then it says 5 cents for each minute. So that will be plus 5 times m, because we don't know how many minutes a person's going to stay on. This says with company Y, it costs 15 cents to connect and 4 cents for each minute. So I can make their expression 15 cents to connect, add 4 cents for every minute. So then it says, write and simplify an expression that represents how much more company X charges than company Y in cents and for n minutes. Okay, well, that means I'm going to see how much more I'm subtracting company Y from company X. The minute I put this negative sign here, this is going to change all of this. All right, so this is really going to be equal to 35 plus 5m, and this is going to change the sign of everything here. So it's going to be minus 15 minus 4m. Well, 35 minus 15, I can group together, so I'm going to group them over here together. Let's see, 35 minus 15, those are my constants. I'm going to add that to, let's see, 5m minus 4m. Now I'm ready to go ahead and do my math. Well, 35 minus 15 is going to be 20. And 5 minus 4 is 1, so that's going to be 1m. So 20 plus m. So I guess my answer would be it's 20 plus m more. And let's see, did I cover everything? Well, it did say to use n for your variable, but whether you use m or n, it's just a variable. I will accept either answer. If you remember to put n instead of n, then that's great for you too. Let's try number 13. Two friends shop for fresh fruit. Jackson buys a watermelon for $77.65 and 5 pounds for cherries. Okay, and 5 pounds of cherries. Okay, buys a watermelon for that amount and 5 pounds of cherry. Tim buys a pineapple for $2.45 and 4 pounds of cherries. Okay, use the variable P to represent the price in dollars per pound of cherries. Okay, write and simplify an expression to represent how much more Jackson spent. Okay, well, let's see, over here, he buys a watermelon for $7.65 and 5 pounds of cherry, and then he buys a pineapple for $2.45 and 4 pounds of cherry. So I'm going to start by making my expression. This one would be 7.65. See, I'm adding, I know there's 5 pounds. I don't know the price, so I'm just going to put P over here. And that's going to be in my first expression. And I'm going to be, let's see, combining it with the expression 2.45 and 4 pounds of cherries. So that's plus 4 pounds of whatever that price is. And it says use the variable P. I did to represent the price in dollars. We don't know what that price is per pound of cherries. Write and simplify an expression to represent how much more Jackson spent. Okay, how much more Jackson? Well, Jackson's the one that bought this, so we're going to be subtracting that from how much Tim bought. Well, let's see. Once again, we're going to have to take all these numbers and turn them to opposite, right? Because we're really multiplying by -1 here. So this is going to be 7.65 plus 5p. That doesn't change. And now we're going to subtract. Well, -1 times 2.45 is negative. So we're adding, this is going to be negative 2.45. And then -1 times 4p, well, that's going to be -4p. And now we can go ahead and mix our numbers up since we're adding everywhere. And we could turn this into 7.65. And we're subtracting our like term 2.45. And we're going to be adding that to 5p minus 4p. All right, let's go ahead and check this out. Well, 7.65 minus 2.45 is going to leave me with 5.2, I believe. We'll just double check that. 7.65 and minus 2.45. Well, that's going to be 0. That's going to be 2. And that's going to be 5. So 5.2. And 5p minus 4p, well, that's going to be plus p, right? 5 pineapples, let's just say, or minus 4 pineapples would be 1 pineapple. So whatever the price is going to be, there's going to only be one of them instead, multiplying it by 1 instead. So 5.2 plus p will be your answer. Let's go down to number 15 now. A rectangular garden has a walkway around it. Find the area of the walkway. If I'm going to find the area of this walkway, let's see, they're talking about just the stone part, not the inside yard with the pool and stuff. So let's see, if I was to do this, which is a garden, I guess we'll call this a garden, even though it kind of looks like a backyard. Find the area of the walkway. Well, first of all, I know I can go ahead and take the entire yard and minus the garden from it, and that'll give me the area of the walkway. I have to remember that area is equals the length times width. So my length of my whole garden or my whole yard is 21 times 21 times 8x plus 6.5. 8x plus 6.5. Okay, and we're going to subtract from it, well, the yard itself is 15, and since it's length times width, we'll be multiplying that by 6.5x plus 5. Okay, and now, well, first of all, we've got to go ahead and distribute our properties. Let's see here. If we were to go ahead and do this, we'd have to realize that we're going to multiply 21 to everything here and negative 15 to everything here. Let's see. I decided to make it a little easier on myself. As you can see, they took the 21 and multiplied it to 8x, right? And then they multiplied it to 6.5, and they got these terms here. They took the negative 15, actually they just took the 15, they left the negative sign there, multiplied it to 6.5x, and then multiplied it to positive 5, and they got 97.5x plus 75. Now they realize that negative sign here is like having a negative 1 here. So that's what they put here, negative 1. Now they're going to multiply that negative 1 to here, and it's going to change all the signs. So this is going to turn to negative 97.5x, and this is going to turn to negative 75. All the rest of these terms stay the same. And now we're ready to combine like terms. I'm going to put my x's together. I'm going to group them together. So I've got 168x minus 97.5x. That's my first group. My second group, I'm going to have 136.5, and I'm going to minus 75 from it. When we're done, we should have 70.5x. Okay, because we take the big number minus the small number, keep the sign of the big number. And then we're going to take 136.5 minus 75 from it to get 61.5. And so our walkway says, let's see, that's the difference. Yeah, our walkway is, this is going to be, this is the area. The area equals 70.5x plus 61.5. All right. Now it's time to go down to number 17. 17. High order thinking. Find the difference. All right, we're just subtracting these numbers. And it's high order thinking because we've got some mixed numbers in here. It really isn't that much more higher order thinking, but let's go ahead and first distribute that negative 1 to everything, right? So this is going to be 7x minus 6 2/3. And this is going to be a negative times a negative, that's a positive. And a negative times a positive, that's a negative. Now, let's go ahead and group them together. We got 7x plus 3x. And we have negative 6 2/3 minus 4 3/4. Now, well, first of all, we know 7x plus 3x, that's going to give us 10x. Now for the hard part, we're going to take these terms and turn them into improper fractions in order to go ahead and combine them. We're actually adding them together because they're both negative numbers. So let's see. If I was going to do this, I would say that, we could also just take this fraction, okay, and turn them into different fractions that are equal by realizing 3 and 4, their common denominator is going to be 12. So, let's see. So go ahead and turn 3 into 12. I have to multiply it to 4. If I multiply the bottom by 4, I multiply the top by 4. So this is going to give me negative 6 and 8 over 12. And then over here, in order to turn this one into 12, we're going to have to make this into times 3, and that would be multiplying the top by 3. So this would be negative 4 and, let's see, 9 over 12. And now we have to think, well, can we take 8? Remember, we're adding these together. We're not subtracting them. Well, 8 and 9 make 17. So this is going to be 10x let's see, minus, because it's a negative and negative, it's going to make a bigger negative. This is going to be 6 and 4 make 10, negative 10. And 9 and 8 makes 17 over 12. Well, we know that 12 goes into 17 once with 5 left over. So this can really turn into 10x minus 11 and 5 over 12. Now some of you are thinking, Mr. Mendez, why didn't you go ahead turn these improper fractions first? Let's see what would have happened if I did, okay? We're just going to rewrite it on this side like we did. I would have had to take, let's see, 3 times 6, that's 18, 19, 20, so that would have been 20 over 3. And I would have been combining that with, that's 16, 17, 18, 19, minus 19 over 4. And once again, we would have had to take our denominators, and that means I would have had to multiply this by 4. So this would have been negative 80 over 12. And over here, this would have been a negative, and 3 times 19. 19 times 3, let's see. 7, the 2, that's going to be 57. So that would have been 57 over 12. And I would have had to add these together. Let's see, 8, 9, 10. That would have been 137 over 12. And now we have to see how many times 12 goes into 137. Remember, every fraction is really a division problem. So if this is 137, and we're dividing it by 12, well, first of all, 12 goes into 13 one time, leaving 1 left over. And then 12 goes into 17 one time. Okay, and that would have gave me a remainder of 5. And once again, you can see our answer would have been 11 and 5 over 12. 11 and 5 over 12. And since they were both negative, it would have been a negative 11 and 5 over 12. So our answer, final answer, is going to be 10x minus 11 and 5 over 12. Well, next we're going to number 19. Use the expression 1/4 p minus 1 minus 1/3 p. Okay, write the expression without parentheses. Well, okay, and then simplify your work. If I do this without parentheses, it would be 1/4 p. I have to subtract or multiply this -1 to everything. So -1 times +1 will give me -1. And -1 times a -1/3 p will give me a +1/3 p. And then it says, simplify and show your work. Well, now I've got 1/4 p plus 1/3 p. So let's go ahead and rewrite this to put our expressions together. That would have been 1/4 p plus 1/3 p. And then -1. See, all we did was rearrange these numbers. Well, 1/4 p plus 1/3 p, we have to make these denominators the same. I'm going to do it the quick way. We know that they're going to be 12, so that's going to turn this into 3 over 12 p plus 4 over 12 p. -1. Well, 3 plus 4 is 7, so our final answer is going to be 7 over 12 p -1. The last one we have is B, that says use a different method to write the expression without parentheses. Oh boy, do not simplify. Okay, well this could have easily just been, let's see, we had 1/4 p -1, minus 1 minus 1/3 p. To do this simply without parentheses, we just could have put 1/4 p, since we don't have to simplify. 1 times -1 is, 1 times a -1, because remember it's going to be a -1 here, would be -1, and this would be a plus 1/3 p. And since we're not simplifying, we'll stop right there. Okay, that's all of them that I had to do, and that took quite a while. Good luck on the ones you have to do, and I'll see you tomorrow.